Astronomers reveal the hidden magnetic skeleton of the Milky Way.
The Milky Way, our galaxy, holds a fundamental invisible secret to its existence, a vast magnetic field that acts as a kind of invisible skeleton, preventing its collapse under the weight of gravity.
Without this field, everything would collapse. Now, a team of astronomers, led by Professor Joanne Brown of the University of Calgary, Canada, has managed to map important parts of this hidden structure with a level of detail never before seen, revealing surprises that change what we thought we knew about the organization of our galaxy. The researchers used radio wave observations captured by a telescope at the Dominion Radio Astronomy Observatory in Canada. They scanned the northern hemisphere sky at various radio frequencies, which allowed them to separate overlapping signals along the line of sight and track the behavior of the magnetic field. The main trick was measuring a phenomenon called Faraday rotation, when radio waves pass through ionized gas in the presence of a magnetic field. They undergo a twist in their orientation. By observing how this rotation varies from place to place and with different frequencies, it is possible to reconstruct the shape and direction of the invisible field around us. The result was a very complete dataset, called GMIMS, which is now available to the entire scientific community. With it, the team discovered unexpected patterns. Generally, if we could see the galaxy from above, the magnetic field rotates clockwise, but in the Sagittarius one of the spiral arms of the Milky Way, it rotates in the opposite direction, counterclockwise. For a long time, no one understood well how this change of direction happened. Now, thanks to the new data, they have proposed a three-dimensional model that explains everything. The reversal is not abrupt, but occurs diagonally in space. From our position on Earth, this appears as an inclined transition on maps, solving an old mystery.
This magnetic structure influences several important processes. It guides the movement of interstellar gas, helps determine where new stars are born, and controls the trajectory of cosmic particles traveling through the galaxy. A better understanding of how the magnetic field is organized today is essential for creating models that predict its future evolution and, thus, for understanding the history and destiny of our entire galaxy. The studies were published in 2 articles in the Astrophysical Journal at the end of January 2026, and the release of the data opens doors for other scientists around the world to continue their investigations. Little by little, what was invisible is being revealed, showing that our galaxy has a much more complex and fascinating magnetic architecture than we imagined.